This is going to work better. Welcome to what's going to be a very rich, I hope, set of presentations. Mike Delaney and myself, Tein McDonald, are convening this session. It's about the evolution of rainforest restoration on the New South Wales North Coast over the past couple of decades. There have been significant evolution in practice. We've got substantial progress in the recovery of a threatened, endangered ecological community as it is now. It's involved partnerships with private and public organisations, landholders, local communities, Indigenous groups, schools and others. So these are key, these partnerships. Now, I'd like to introduce Mike Delaney. Mike has been involved in ecological restoration for 35 years. He set up a rainforest nursery in the Big Scrub area in 1978, and he gradually moved into the ecological restoration industry, working as a field contractor, and then he joined Envite Environment in '93, where he's now the National Operations Manager. And Mike is also a life member of the Big Scrub Land Care, joining the group in '92. I think you formed the group, but you're too humble to say that you're one of the founding members. So thank you, Mike. Ecological restoration practice in northeast New South Wales.
Thanks, Tein. The Big Scrub, just to explain, get some background and overview, the Big Scrub was the largest expanse of subtropical rainforest in Australia. It covered an area of about 75,000 hectares between Byron Bay, Ballina, Lismore in northern New South Wales. Tragically, it was cleared for agriculture. By 1900, only 1% remained in the form of 100 small remnants scattered across a largely cleared landscape. Over the following decades, an array of environmental weeds caused increasing damage to those remaining remnants. The small scattered remnants of the Big Scrub are mostly less than 5 hectares, although there are some of the national parks larger than that, in an area that covers less than 1,000 hectares in total. The critically endangered lowland subtropical rainforest remnants contain significant habitats for the conservation of biological diversity, including two threatened species in the flora area and 12 threatened species of fauna, all listed under the Australian Environmental Protection and Biodiversity Conservation Act. Why was it such a successful clearing? Well, the new landowners, when they moved to the area in 1860, had a great incentive from the government of the day, and that was they gave them about 100 acres, and they said, if you can clear it all, it's yours to keep and to farm. So naturally, that was a great incentive. And there were certain circumstances where people who didn't clear their land had it actually taken off them and given to people who were able to do it. So that program worked magnificently, and I've always been hoping that there'll be a government program that works so splendidly in the reverse one day. Just to get an idea where the actual area we're talking about is, that red line is the boundary of the Big Scrub. So we're in northern New South Wales. We're about 2.5 hours drive from where we are here south. You've got the town of Byron Bay, which is outside the Big Scrub zone. There's Byron Bay, Bangalow, very common tourist towns these days. You've got the mouth of the Richmond River where Ballina is situated, Alstonville, and then west of Alston to Lismore. North to south, it was roughly about 35 kilometres. East to west, roughly in places about 25 to 30 kilometres. So these little dashes in here, the little dashes and squares and triangles, they're the actual remaining remnants. So you can see that extremely fragmented, and some of the bigger ones up here bordering onto the Nightcap National Park around Rocky Creek Dam. We also have lots of camphor laurel in that zone, and I won't go too much into that. We'll talk a little bit later on about that. So caring for the remnants, well actually to get before that, the reason what happened and how did we start this program in the first place, and I guess the new settlers arrived in this area in the 1970s, completely different I guess from the early settlers. They came not as farmers, but they came as sort of lifestyle people I guess, saw the beauty of the area. Many of them learnt the history of the natural area. And like myself, I know when I first found out about what had happened at the Big Scrub, it really touched me deeply, to the point of tears when I read about how the destruction occurred. It was not until the 1990s that the Big Scrub Land Care Group was formed, 1992, beginning of land care, I guess. And in 1993, Environment also formed. And so the two groups have worked together collaboratively over those years in the restoration program. But looking after the remnants was the first fundamental issues that we had to deal with. The remnants were in shocking state. The larger national parks, some of those weren't too bad, but the smaller remnants, mostly on private land and on council reserve land and Crown Reserve, were in an absolutely shocking, degrading state. So we partnered with all the people we could possibly partner with, all the private landowners. We approached the private landowners who had remnants. We approached National Parks and Wildlife. We're dealing with 4 local councils and other community organisations. Over the years, we've developed funding to the tune of about $5 million with 40 projects that we've been running. These projects have enabled us to contribute to the ecological restoration of more than 50 lowland rainforest remnants of the Big Scrub area and totalling about 600 hectares. GIS mapping is now used to identify further remnants. Restoration plans are developed to document the environmental values and the vegetation condition, and strategies and actions to guide the ongoing management of the site. Remnant care primarily revolves the long-term control of at least 140 weed species that threaten the survival of the lowland rainforest at every level. Big Scrub Land Care employs professional bush regenerators to treat the initial weed infestation and to control the weed regrowth. Bush regenerators also carry out ongoing monitoring to record improvements to the rainforest vegetation condition and weed occurrence. You might ask where this money came from. Well, a very big supporter of the group has been the New South Wales Environmental Trust. We've now just been successful with our 13th rehabilitation grant from them. We've also had a 6-year project with the New South Wales Environmental Trust at the Big Scrub Flora Reserve. We've also got money from pretty well every grant that's been on offer from federal and state, local government, philanthropic organisations. So largely to date, that is where our money has come from. But more recently, the Big Scrub has set up a foundation with donations, and we've had some large donations. We've got $1 million in a fund. The interest of that, we're hoping, will continue to be able to carry out the ongoing regeneration activities that obviously need to continue. This is a typical example of a remnant. This is one called Little Benny's. Little Benny's is downstream from Benny's, so it's its little brother. A typical sort of remnant got some on a riparian, Cooper's Creek here in the Eureka area, where there's a great cluster of remnants. You've obviously got some issues here around the riparian zone, largely not a bad condition, little remnant, but that's typical sort of grassland surrounding a remnant with beef cattle and dairy cattle situations. A bit of a wider view of that area. This is Little Benny's in here, the creek. I think the important thing you look at here is just you've got this remnant crammed in by activities either side of it, rural activities. You've got some little remnants here on the slopes, and in Eureka there are lots of little remnants that we haven't started to work on. Some of them are only 100 square metres or so. But what you've got as typical of the northern New South Wales area is these steeper slopes that, after the clearing of the Big Scrub, the farmers realised these areas were too steep to farm, or they just neglected them, or the stock didn't wander up those slopes as much, and over the period of time they turned into camphor laurel. And I won't go too much, as I said, into camphor laurel and the work that's going on there. Dan will speak a little bit later about that. We also have other issues with our remnants. Here's one in a typical situation now with the macadamia industry, our major primary production in the area. This little remnant called Molly's grass, it's in the Rouse Mill area. It's completely bounded by the macadamia farm. In fact, we have 2 farms. The actual remnant is split in half with 2 owners. So a nice little remnant, not so many issues there. Away from a riparian zone, we have mainly the small bat colony, which is causing some problems, but with weed issues. But other than that, the issue with those sort of things, how can we expand on them? The farms have absolutely encroached on them. I guess what you can see here as well is that there are remnant trees that the farmers have left. There's a big fig there. I think we've got a big red apple in one of those sort of locations. So you do have isolated trees as well as the camphor laurels that are causing some sort of small linkages. Lots of weed issues, Madeira vine, some great sites that we work in as well. This is at Wanganui Gorge, and some great examples of some old growth trees and some of the remnants. Re-establishing the rainforest, that's something that's we often do to create a new patch, expand a remnant or connect two remnants to enrich a patch. To date we've facilitated the planting of 1.5 million trees, covering an area of about 300 hectares, and that's 1.5 million that have survived, not that have been planted and so on. This is a linkage planting we did between Morton Scrub, there's Morton Scrub in the top there, and coming down to that little remnant, little bennies that we saw before. Most of those plantings were done by Green Army, so over the years we've utilised all those labour market programs, Green Army and the previous model of Green Corps in the 90s to value add to our projects, planting trees, doing a lot of the hard yak sort of primary work and some of the remnants. We've done some planting also at a nature reserve in Victoria Park. Tein's going to talk a little bit later about that. This is the back part of the Victoria Park. Over the years, cleared lantana, we had some regeneration occurring naturally, added some trees in there as well, guarded against wallabies. Then we have some canopy cover coming up very quickly to June 17. Pretty well got a total canopy cover. The next big thing the big scrub's involved with is just community engagement. When I say just community engagement, I think it's extremely important, it's just as important as everything else that we do. We have biannual Big Scrub Day. This year's the year for the Big Scrub. Every second year we have field days at various locations. We've produced publications that assist landowners for the fundamentals of rainforest restoration work. We boast a membership of about 350 people and produce regular informative newsletters and promoting lowland subtropical rainforest. This is the Big Scrub Day. It's a huge day out at Rocky Creek Dam. The keynote speaker in 2016 was Bob Brown, who attracted quite a crowd. 5,000 people turned up. We have field walks that happen on those days with lots of educational tours and educational talks in the marquees. We also have field days. We have smaller groups. We show them what techniques we're using, what's working, what isn't, what we'd like to see happen, and get people enthusiastic. Production of these manuals. This is the second edition of the manuals. There's a third edition that's being drafted at the moment. There's some further editing to that. At the end of the day, that's exactly what we want to see, is our intact canopy-covered rainforest. Just to finish off briefly, where the Big Scrub was cleared in 40 years, virtually 75,000 hectares was cleared, took them 40 years. We've only been going for 25 years. I think we've achieved a lot more than what anyone would have dreamed we would have achieved, and a lot more than anyone would have given us credit for what we might have achieved. But one of the things we've learned is we can't completely rely on government funding, which is why the foundation has been set up. But I do believe not just for the saving of the Big Scrub, for the saving of our natural environment all over this country and all over this planet for that matter, is going to be driven by people, and people with passion, people with enthusiasm, people with commitment. That's what generally runs in this industry, but for us to survive into the future, people at higher level need to know that's the way we've got to go. Thank you.
Thank you very much, Mike. So we're going to leave questions to the end. We're trying to keep a little bit of time at the end for questions. So if you can keep your eye on the question and bring it up later.
Do I need to introduce you, Tein?
No.
That's all right, I got you. So Tein's been involved in the ecological restoration for 35 years as well. And we've known each other for that long. Firstly as a practitioner and later as a teacher, planner and science journal editor. Everyone would know too, she's highly involved with the organising committee with this conference. Frances might need to get the next one.
Thank you.
And Tein's talk today is to draw on some old and new data tracing rainforest recovery at a particular Big Scrub site called Victoria Park Nature Reserve. It's to illustrate some of the processes and also work on a larger scale.
Great. Thank you. Thank you, Mike. Yes, and you can see that the main driver, I suppose, or the main vector are these birds that actually transport the seed of rainforest trees. So I'm going to show you just some results of monitoring at Victoria Park over about a 30-year period. So this is what was created by our forefathers and mothers, a beautiful pastoral landscape devoid of rainforest. And it was the result of a great deal of hard work by a lot of people, but as well as the people who worked hard to cut down the timber for various products, we had people who were prepared to work on the conservation of big scrub right from the beginning. So here we've got the 1930 Scrub Reserve Committee at Alstonville, headed by Ambrose Crawford. I think what we're seeing is just restoration was never a mainstream activity, but it is becoming so. And similar activities started occurring in the late 70s and 1980s. This is a planting day at Victoria Park, Alstonville, where the Richmond Valley Reforestation Association and National Parks collaborated on a planting, and what you can see is I believe it was buffalo or kikuyu, someone else could interject and let me know what that grass was, adjacent to what was a remnant area. Now, that diagram shows the square remnant and the triangles above it and to the right of it were cleared pasture. The site, I believe, was a Crown land, and it was used for picnicking by the general public, but it was also lightly grazed. So it was maintained as grassland around it. So that's before treatment in the 1980s, and it was advised by Alex Floyd, a rainforest ecologist of very high standing, who has brought to the restoration community a great deal of insight about rainforest ecology and gap dynamics, and he recommended quite early on that we need only plant early successional species, and that the natural vectors, the birds and bats, would be able to bring in species from the remnant, bringing later phase species. So in fact, as well as advising on these plantings, he personally poisoned some of the isolated camphor laurels that were in the grassy area. And on the top left here you see a photo he took 2 years after poisoning with camphor, and you can see 3 or 4 native species present there. In 1983, 5 years after, you can see they're becoming more complex and moving up. In 95, 16 years after, you wouldn't know that it had been a camphor laurel. So we're talking about a situation here where there's no planting whatsoever. This is a natural succession process. And the other day I took a photo 39 years after the poisoning, where I had to have the camera in portrait orientation because I couldn't pick it all up in landscape. And we have the records to show, how many dozens of native species are under there, but I just didn't have them to hand at the moment. There was a phase, 83 to 93, when lantana colonised many of the gaps, so regeneration teams were employed, expert regeneration teams working out the lantana and various other weeds, and subsequently we had a high density of diverse native rainforest species underneath, and characteristic were where the camphor laurels had been poisoned, native figs colonised, including strangler figs that then, it's quite instructive when you go and look at the site now, you can see that the roots have wrapped themselves around the camphor, and it's quite hard to see what it was previously like. Sorry. 12 to 18 years after planting, and it's a 12 to 18 year range because the planting dates were different. So I undertook this monitoring in 95. 68 species were found in the plantation, and that represented 72% of the 94 species in the remnant at that stage. Now that's trees only. Now most of those found were later successional. So that's 45 out of the 68 were later successional, and by that I mean a combination of late secondary and mature phase. Of those, 56 were flying frugivore spread and 8 were wind spread. So back to the birds. Holmes in 1987 listed these 8 species as being some of the more common bird species, flying frugivores that utilise plant species. Some of them are more generalist than others, and it has to do with gape size and so on. And a lot more work has been done by Carla Catterall's team up here about the relationship between birds and dispersal, and we can thank Carla and her team for fantastic insights showing us which species we might plant to attract which birds that might then be able to bring other species. So when I did the monitoring, I compared 3 different types of plantation with a treeless opening, some tall isolated remnant trees and some poison camphors. And the orange highlighted ones are showing higher results for the plantation that had an open canopied pioneer tree rather than a closed canopied pioneer tree. And that was not hugely different to the effect we were getting with tall isolated remnant trees and poison camphors. There's a lot more information in this particular table than you can absorb right now, but suffice it to say that we're getting an increase in number of species and an increase in height of those species. Well, no, we're finding that out later when we do subsequent monitoring, but we're getting more later phase species on the sites as time goes on. Here we've got some graphs that depict that, but I'm not going into it because I'm making up for the time that I wasted on the previous speaker. So here's the 2018 Google Earth image. Now imagine that before, had that planting not happened, it's very likely that had the cattle still been grazing there, it still would have been kikuyu and buffalo in those 2 triangles. And it now looks like quite a diverse canopy cover there. You can still pick out the remnant, but we're getting excellent results. So those red dots were the tall, isolated remnant trees, and the yellow stars, the poison camp laurels. Plantation B was the one that was most successful, so I subsequently monitored those in 2002 and 2018. And we're getting here a continual increase in later phase species in the stratum above 2.5 metres in height. And even over 5 metres, we're getting now some of the individual trees moving up in 2002 and increasing in 2018. And it could be that some of the earlier phase species are moving out of the system. That's why the data is lower for the earlier phase species at the later readings. So if we want to split the mature phase and late secondary up again, we're seeing increases again. So it's not just due to late secondary. And wind, we worry about the wind dispersed species. I'm often banging on about booyong because white booyong is wind dispersed, and it was the dominant in all these rainforest associations. It was not very well represented, and it's still not very well represented, but there are other wind dispersed species in the system, and that is improving a little. So does this matter? We're only looking at now a triangle. Yes, it's bigger than it was, But what is that contributing to the broad project of restoring big scrub landscapes? So the key is there needs to be connectivity, and those small number of remnants are terribly important as seed sources for the broader scale landscape restoration project. Camphor laurel, as you will hear later from Dan, is actually acting as a receiving site for the dispersal of later phase species. It's a successional, they're early successional stands, and they are increasing in scale in the big scrub landscape. So these remnants are terribly important to supply the seed source of more mature phase species. Whether we have enough of these remnants is, well, we know we haven't. We know that big scrub landscape is working hard to create what are artificial remnants, if you like, artificial clusters of more mature phase species. I hope someone's watching my time here. And here we've got a recovery wheel for the standards. It's looking great at the remnant level, but what we need to think about now is the whole landscape level. So the implications are, look, Victoria Park is a microcosm of similar processes that are occurring throughout the big scrub. There is absolutely no doubt about that. There's an increasing amount of regrowth. Have we enough plantations to provide seed sources? Tony's going to be talking about later about how we increase that, increase the ecological functionality of those plantings so that they can act as very good seed sources. And my question continues to be, can we somehow strategically locate those plantings? But that's questions for later on. So that's all from me, and we'll go to the next speaker. Thank you. So let me introduce Dan Cox. He's a restoration ecologist working for Envite Environment. He's been working here for the last 13 years in northeast New South Wales, and he's overseen the restoration of big scrub rainforest remnants. And today he'll detail the methods being utilised in transforming disturbed camphor laurel dominated sites back to subtropical rainforest. So we're talking here largely about camphor laurel conversions.
Hi, I'm Dan Cox. I'm an ecological restoration ecologist for Envite. I'm going to talk to you about camphor conversion to rainforest in northeast New South Wales today. Camphor laurel was introduced to Australia from China and Japan in the late 1800s. It was introduced as a windbreak tree and promoted as a good shade tree for livestock, schoolyards and parks and cemeteries. The trees can reach maturity within 10 years and are long-lived. Some individuals in China are at least 500 years old. A large mature tree can produce over 100,000 fruit a year and reach approximately 20 metres, some more, some less. Camphor is spread mainly by frugivorous birds and can rapidly colonise disturbed areas and neglected agricultural lands. Camphor forms dense stands effectively shading out and outcompeting most native and exotic vegetation. Here's an example of some camphor laurel at Alstonville. So the stem on the right hand side, like that, you couldn't get your arms around. It's just absolutely massive. You can see how much shade there is in the understory. So effectively outcompeting everything around them. Here's a map showing the map distribution of camphor infestation in the former big scrub area. You can see that in the red. Generally the cleared landscape, fertile basaltic soils, high annual rainfall, and just perfect conditions for camphor laurel and other environmental weeds to colonise. Here's an aerial image that I took off Google Earth showing an area in Northern Rivers in 2010 and later 2018. You can see on the image on the right there's just a massive expansion of Camphor laurel in that time. It doesn't look like the landholders really done much to hold it back. So yeah, you can see it's pretty invasive. 8 years isn't really a long time in the whole scheme of things. So some people might see that as a negative thing. I feel it's actually a positive thing. If those camphors weren't there, it might still just be grassland, and as a habitat that's pretty poor for rainforest regeneration. But well, on the aerial image you can see it's all camphor. There's a high chance there's actually a lot of rainforest regenerating under that. So camphors benefit biodiversity in a number of ways. They're a key food resource for native fig birds, pigeons, doves, and some of these species are actually threatened species. They provide habitat for a lot of other animals as well. Well, another threatened species, koala, while it doesn't feed on camphor laurel, it does definitely use it as shelter in hot weather and use it as a way of moving from one feed tree to another. As I said before, if the camphor wasn't there, there's a fair chance there'd be no trees there at all. So I feel it's better to have any tree rather than no tree. And with the presence of that tree and attractive native birds, the birds are a natural vector for moving rainforest trees from remnants out into past pastoral areas. So it's a key tool in expanding our big scrub rainforest. There's just a couple of examples of habitat. So nice cute koala and brush turkey taking advantage of the large amounts of leaf litter present in a camphor forest. So ideas utilising camphor for conversion, it's pretty well in line with any of our general bush regeneration aims. Initially we're really just trying to open up the understory, let some light in and get the natives regenerating from the seed bank that's already there. Of course, once we open things up and try to get things happening, it's not just natives that are popping up. Generally, it's more exotic than native. So in that initial stage of opening up a site, taking out any canopy trees or even opening up the understory, we're looking at a high level of maintenance, probably maximum sort of 8-week interval visiting sites and keeping on top of the weeds and ensuring the native seeds that are regenerating are unimpeded by the weeds regenerating at the same time. So in camphor conversion work, we always start in the lower strata, hand pulling, cut scraping and painting woody weeds and vines, and spot spraying any exotics remaining. Stem injection of woody weeds such as privet and camphor in the under and mid-story should also occur at this stage of the work. For staged camphor control, stem injections of the canopy should be undertaken strategically. So trees which are directly competing with other native trees present in the canopy and mid-story should be controlled first. Other camphors in the canopy should be controlled if there is adequate native cover in the mid and understory to take their place. Further thinning of camphors in the canopy can occur strategically to allow extra light resources to reach the ground as required. And for patch camphor control, all camphors in a designated area is opened up and stem injected and the area maintained. Here's an example of 1 year after we opened up the understory. So this was a stage camphor conversion where we weren't actually taking out all the canopy. You can still see there's a lot of shade on the right hand side in the after shot, but you can also see there's young regenerating natives there too. So it's definitely a positive change. Generally underneath our camphor we get low light tolerant weeds such as privet occupying. So you see on the left hand side that's just hundreds of stems per square metre of privet, solid privet. Here's an example of what we do to the camphors when we're stem injecting using a 10mm drill bit and cordless drill. It's another one. So we've got working in pairs, filling the holes as soon as possible after we do the holes with the drill. We're filling it with glyphosate, diluted 1 to 1.5. So there are 3 types of camphor conversion, which can be defined as patch, staged, or combinations of both with revegetation. Patch involves systematically controlling all camphor and other environmental weeds in patches up to 1 hectare at a time. Staged involves strategically controlling all camphor laurel over several years. Patch and stage revegetation involves controlling camphor laurel, and rather than depending on the natural regeneration that responds to the removal of the camphor, you plant a full plethora of native rainforest species in its place. In a study by Canowsky and Catterall in 2007, it was found there was not one way that works better than another in camphor conversion. They all work, but at different scales of time and cost. I'll just talk about strengths and weaknesses of the different techniques. So strength of patch removal is it removes all the competition for the native vegetation and stimulates maximum regeneration of the native seed bank, because you're getting maximum light hitting the ground, promoting the regeneration of the seed bank. And the weaknesses is it's a high initial cost in the first year of the project, as you're doing all your stem injection, and a higher level of maintenance associated with the high levels of light hitting the ground and promoting regeneration of your natives, but also your exotics. And if you get an extreme climatic disturbance or a disturbance event occur in that initial time after you've had your initial flush of natural regeneration, you might, say for example, expose all that regeneration to fire and knock out a whole generation of regen. So that's a bit of a weakness. And short-term loss of habitat for all those species of animals that we were talking about before. And short-term projects could revert to exotic-dominated forest if work is not maintained. So if you've got a canopy of camphor, you're limiting what sort of weeds that can really persist under there in that low light condition. You open that area up, you open that site up to every different weed in the northern rivers, which is a massive number of serious weeds you could be opening up to. So here's a successful site after 3 years on an environmental trust project. You can see a great number of native rainforest trees, good diversity, and really occupying that understory nicely. But still high levels of light getting through, so still requiring a fair bit of maintenance at that stage. Here's an example of what sort of response you can get after taking the canopy out. So this is after 12 weeks, the canopy's taken out, and bang, you just got total ground cover of tobaccos and annuals, and yeah, there'll be natives in amongst it, so it's pretty slow going through and working those sort of sites. It's probably just been left maybe 6 weeks too long. And probably had plenty of rain in that period too. Strengths and weaknesses of stage removal. Retains forest structure, retains some canopy cover, reducing maintenance levels, removes competition to existing native trees, able to take the place of the camphor, still promotes the regeneration of the native seed bank, but not as prolific as whole patch removal. It spreads the primary control costs over a longer period of time. Regeneration response is staggered, so it's better able to cope with climate or disturbance events. And strategic retention of exotics can reduce the risk of erosion on slopes and buffer against edge effects. Weaknesses is that if you retain the mature camphor, they continue to produce those 200,000 or 100,000 seeds a year, so you're still maintaining a lot of camphor on the ground during that period. And natural regeneration can be slow in low light conditions, and complete removal of the camphor laurel may not be possible in a short period of funding. So here's an example of a stage removal where everything in the understory and almost up into the mid-story, a lot of privet was removed here, and it's just sitting in a stable state. Natives are able to regenerate and minimal maintenance is required. It just needs a couple of visits a year and it stays under control and still promoting plenty of natural regen. So here's a site that was, it was still a staged response. So you see there's still plenty of shade on the ground, but that's still not enough to prevent mass germination of canphors. So there's a lot of canphors in through here. Pretty slow run through there to get on top of all that, but there's still plenty of natives if you look closely regenerating. All right, sorry, I've taken too long. There's some more successful things. I guess with revegetation, you re-veg with your camphor conversion, you're bringing in fruit that wouldn't... Oh, okay. All right, well, I'll talk about the strengths and weaknesses of revegetation with it. So like stage removal, not stage removal, patch removal, it takes away all your competition with your native vegetation, but you can also improve your species diversity. So some of these sites are so highly degraded, you're not getting your full species suite that you would like in in a rainforest, so you can really supplement what species you've got on that site by planting. But it is very costly. Cost of planting a tree compared to regenerating is significant. And then if your camphors are falling on top of those trees, there's a significant loss there. And then some of these sites, they're actually chopping the camphors down after killing them, then planting. So you're looking at $1,000 a tree in some places. So it's, again, very significant costs. I'll just show a successful re-veg, and there's some really good regen in response to camphor control. Thank you.
So by re-veg you're meaning planting?
Yeah, planting. Yeah.
So in planting you're still getting regeneration as well as the ones you plant?
Yeah, and probably more because there's even more disturbance associated with planting a tree. You're probably getting more regeneration. Is that on?
Yep.
Yep. Yep. Is that on?
I don't think so.
No?
Up.
Yep.
I think it's up. It's picking.
In the revegetation sites or the planting sites, we are getting more natural regeneration in response to digging a hole and disturbing the soil as you go as well. So it's very effective if you've got enough money.
Thank you very much, Dan. That's really good. Thank you, Dan. I'd like to introduce Ian Stych. Ian spent over 20 years as a zookeeper in Scotland, also in New Zealand and South Australia, and then Victoria before moving to northern New South Wales, so northern rivers. So we have the benefit of having someone who's actually got knowledge about fauna, which is bloody brilliant. So he's worked as a bush regeneration supervisor with Environment for the last 10 years. And Ian's talk today will be on his work over the last 10 years, working in the Wanganui Gorge and the techniques used and the results achieved in that particular site.
Thank you, Tein. See how well this goes. Time started. So Wanganui Gorge, I suppose the best thing is a very good hotspot. It's a very extremely diverse biological hotspot, really good biodiversity. Location is it's a 78 hectare subtropical rainforest located at Huronbrook. So Cooper's Creek running along the eastern boundary is situated between Goondiwindi National Park and Nightcap National Park, so extremely important there too as a wildlife corridor, and it's recognised as a wildlife corridor, also a climate change corridor. So it was privately owned by Donald Pugh and Sue Walker until it was incorporated into National Parks Estate in 2014. A couple of pages on. So project funding, because this is a big issue of any project. We were fortunate here, we had 3 New South Wales Environmental Trust Restoration and Rehabilitation grants of $100,000 each stretching for 3 years. So that goes up until 2020. Australian Government National Land Care Program Threatened Species Recovery Fund, so $120,000 for that, and that's still extended to 2019. And a small level of funding through North Coast Local Land Services and a Borland grant. And Green Army teams were managed by Invite on site for a pretty intensive 2 years, and they were really good for cutting lantana tracks, doing totem pole work and a lot of handwork involved, and working with the regen teams on site. And funding through New South Wales National Parks this year, another $20,000, which has gone to systematic follow-up through some of the older work sites, which again it never stops, it's just ongoing, but it's really worthwhile doing. So there's about 40 hectares that's been worked in the southern parts of Wanganui Gorge, or Wampur as we call it, and now there's work going on in the northern section as well. One of the biggest problems here of environmental issues was addressed in Wampur Gorge was actually lantana, major lantana infestation. So you can see in the purple coloration here is the darker and the lighter. This is 50 to 90% cover of lantana, really intensive. And it's a major threat to subtropical rainforest because it does actually suppress rainforest regeneration. So the threats to survival of endangered lowland rainforest and the threatened species and flora fauna that occur in it, and a need to restore ecological ecosystem functions, vegetation condition, habitat values, thereby enhancing resilience to climate change and other threats. And it reduces, of course, we wanted to reduce the barriers of movement by improving landscape connectivity. Now, we had originally 11 zones in Wanganui, and in the first 3 years of work, we then changed this and broke it down to 6 zones. So basically it updated because areas which required low levels of maintenance were grouped together, and areas where primary restoration work had not been yet implemented, formed another zone. And then with two separate zones, areas were of the same stage of restoration and required similar management. These areas were labelled as one zone, so of course then we had 3A and 3B. So you can see a few of those in the map there. So some of those were quite widely separated as well. So commencement of works. So in 2009 was when the actual on-ground work started, and that was done with a tractor. We did about 2 hectares, and that was in September. Tractor method is a really good one used by Ralph's Water, or actually started with Ralph Woodford. So major disturbance going through. Of course, you've got to have tractor access. That's one of the limitations. So there was an area that was quite flat, and that worked extremely well. So we've used other areas in dense areas of Lantana. We're controlled by a range of methods. So tractors I mentioned first off, and then foliar overspraying, splattering with a splatter gun, which is gas powered, splattering with backpacks, foliar overspraying with a quick spray unit, which can pump out a large amount and do quite a big area quickly, breaking down with a brush cutter, breaking down manually, hand weeding, including loppers, stem injection, cut scraping paint, and spot spraying. So the slash area initially was handwork. We went through and did a lot of disturbance by pulling out the root systems, because the Lantana, when it's slashed live, it's still a live root system, so we had to go through and do that. And then doing lobber work around the native trees, threatened species, and non-native. So one here point out is red bobblenut, so threatened species. So of course you don't want to spray too close to the threatened species. Of course, there are quite a few restrictions on that, so you can work around them. Native weeds germinated extremely rapidly, so both the native ones and the weed species came up. So we had a fairly wet summer that first year, so we did a lot of handwork around those native species germinating. Because you couldn't just leave and say, I'll wait till fine weather. It doesn't work like that. So you've got to use methods appropriate at the time as situations allow. But very effective means it's a great time to see what was coming up and what sort of numbers. So the methods progressed as the areas opened up. Systematic control of Lantana and other weeds was essential to enhance the resilience of the threatened species, habitat and other elements of biodiversity, and to reduce the barriers of movement by improving landscape connectivity. So spot spraying in the old areas where we'd done the hand work and the tractor work, and then splattering initially with the gas-powered gun in the areas which are steeper and less accessible, and then moving to backpacks in 2011. Cutting tracks through Lantana is the first thing to do when you work it. We did tracks every 5 to 10 metres, and this allowed access into the backpack space. So take a note of this nice looking fern there, because you'll see it in other shots as well. And so we tried a couple of different methods. We always use normally you brush it down, you just bash it and spray it as you go. We use a brush cutter over areas that are accessible to use a brush cutter, so safe to use a brush cutter, because you've got to look at those aspects. It cuts it down really quickly. We also did things like, if I come back one more, going through and smashing it down by hand in different areas that were accessible to do so. Then areas where that wasn't appropriate, we used normal methods of spraying. But what we did found, over about a 3-year period, they end up the same. But of course, the areas where you're going through and manually cutting down with brush cutters, bashing it down manually as well, it speeds everything up. Everything responds fast, weeds and natives, so it requires a lot more follow-up. So more intensive, more money, more time. So the best method, of course, proved to be letting it go in its own course and doing that. As you see a weed, you walk through the Lantana to get that 1 weed or 2 weeds or 3 weeds, and that's a good way to manage a site. Now, connecting the work zones, as the original flat areas were controlled, work focus moved to the upper areas and connecting those upper areas by the cliffs right down to the riparian zone in the east. And this involved, as you saw on the slides there, quite an extensive, varied habitat of access and steepness. Very nice though. And of course, in those upper areas, when you get further and further away from access to water where you can't even drive in anymore, you need water sources on site, but it does actually make it quite complicated for how you're going to get those backpacks full of water up that 400 metres of heavy slopes. And so we still use some of the gas-powered splattering on the higher slopes. You need 2 hands to climb, basically. But you can see in these shots, it gets very intense, a lot of rock, a lot of slippery slopes, and you can't say, weather's lousy, I can't work there for 6 months. It doesn't stop, it keeps going. This last shot just shows the handwork, intensive handwork in the areas which have quite a good resilience and access of natives coming up. So you can't just go in there and spray and wipe out what you've managed to get up as well. I think I said everything there. Adaptive management based on the results, of course, we changed what we were doing depending on what the weather was doing and what the site was responding like. So different parts of Wampu responded differently. We also found that, especially in the area where it's tractor slash, a very thick patches of Lantana, there isn't always a seed source that was originally there. You get a lot of stuff coming up, a lot of that's the early Yes, that one, those ones. So mostly tremor coming up, they're really common. But the bigger seed sources don't get in there, so we actually brought those in from other parts of the Wanganui Gorge to scatter through the areas where we were just seeing the first species coming up. So this is the original tractor area in 2009, coming through to February 2011. So you can see response is incredibly fast. And you've got to be there through that process or the weeds dominate just as quickly. So it does take planning and being aware of what each area you're working in, especially the bigger the area gets, where you're going to be in what week or month of work. So monitoring zone is very important. Monitoring of the program is established on site prior to commencement of works. So the photo here, monitoring stake in 2010 and 27th of August 2010, you can see the results from the first spray. So we include 8 monitoring points, transects initially, so structural floristic information is collated and photos taken prior to commencement of works at the end of the first year and twice in the year 2. Data was entered into the MERV, which is a monitoring, evaluation, restoration, vegetation program, and that information is used then for reports. And of course that helps if you're looking at future funding, you need to show the information of what's happened and how it's happened, sort of results. Photo point monitoring was undertaken annually because that shows then progression on sites. This is showing from 2010 April to February 2012 using a splatter gun unit, so pumping out 300 litres if needed, in an area using long 200 metre hoses, running 2 hoses at once. And this is how fast it responds. And then of course going through after the initial spray has been done, walking, taking out each individual weed, with it being spot spraying in this case, as they came up, so working around the natives. Restoration work areas. So for weed control areas from 2008 to 2011 you can see in the pink. And as you on the earlier map, this is actually where the highest density of lantana was. And then in 2012, 2015, we started spreading out to the primary areas we hadn't worked intensively in, but you have to keep coming back and doing follow-up in the first areas. So it does give you a sort of idea of the scale, so it's quite a large area to systematically work through. This is the monitoring zone 5A, goes real quick, doesn't it? That's monitoring photo point 2. Oh, cool. This is August 2012. So you can see up until April 2014 how that changed. Did that, didn't it? It'll come. So that's the lantana taken out, and then you see what it looks like in 2014 after that work's been done. So pretty quick. This is monitoring point 1, before and after. And what we did now, as you know, with monitoring points, you get to the stage where you just cannot see anymore because 2 metres in front of you or a metre in front of you is just trees. So a drone really comes into zone now, and it's really nice in sites starting now to get pre-drone footage of your site. It gives you a much better view. You can see here quite clearly in the photo point 2, it's a huge area. So the little photo point down here showed you're seeing only a fraction on the edge because the track ran through here. And the photo point 1, you can't see much at all. So this shows quite clearly there's quite a lot of pencil cedars and such coming up, and a really good vegetation through there now, because there's actually, of course, as you know, the photo point, if you're looking uphill, it can flatten out then go up again, so you actually could be missing a huge area seen on a flat scope. Drone footage captures it much more effectively. Already restoration in rainforest at Wanganui progressed to a stage where weeds have been very effectively replaced by young rainforest. Habitat for threatened species has been increased and connected across the southern 40 hectares of property. So this provides a key habitat link across the gorge between the 2 national parks, and fauna monitoring is demonstrating the works are effectively increasing connecting habitat for the threatened and common species. The outcomes of Wanganui Gorge have been met pretty well, so strengthening resilience and regeneration capacity of the high conservation value vegetation, lowland rainforest in the New South Wales North Coast, and threatened species and flora and fauna through strategic bush regeneration works. So great environmental outcomes have been achieved on this site through cost-effective restoration actions. Bush regenerators and landowners have restored critically endangered lowland and subtropical rainforests, linking Nightcap National Park and Goondiwindi National Park, with 2 trust-funded projects restoring 40 hectares. So the site does provide habitat for 10 threatened species or plant species and 18 threatened fauna species, with a further 69 species in a 5 kilometre radius. That's why it's such a tremendous hotspot. Effective field days involving landowners and community were held throughout the project, with 131 attending 3 field days over the course of the project. So we included good workshops showing techniques we'd used, sites throughout the workshop, so it's quite an intensive day of hard walking. And again, you've got to let people know in advance what they're expected to, well, we're of course 3 minutes ago, we've got a bit more to go yet. Actually, not too bad. What we've started this year with the new funding from national parks, or this is actually for the Save Our species. There's fauna monitoring by David Charlie of Wild Search. So Environmental Services is now demonstrating that bush regeneration works has been effective in expanding and improving fauna habitat, including threatened species. There's 3 sites used: primary, older region area and a newer region area. So you can see here quite clearly on the left the number of threatened species, that's the overall number of birds through the old forest, the older region work and the newer region work. But even here, the newer region work isn't that new anymore. So it would have been lovely to have got stuff in the early days. So basically it's showing, and it was tremendous too, with these lantana patches, you've got old remnant rainforest around them, so that adds to the lake or access of the birds to those areas as well. I think that's it. Yes, thank you very much.
So the amazing speed with which you did that, you don't have to disappear. You've earned yourself a question. Yeah. So does anybody have a question for Ian?
Mike? it's probably that's probably about 500,000-600,000 now. Less. We've got 300,000 for those 3. Yes, it's pretty impressive. 40 hectares in the South Wanganui Gorge. So now they're working in the northern Wanganui Gorge, which will connect up those areas. There's a beautiful bit of rainforest in between. So they're now coming in from Wanganui, which is a much longer way around. But very impressive. It's a lovely site to work in. So that's pretty good for me and our team.
That's great. The only question I had was the drones. You use those to get the aerial imagery. And does that mean that you can get befores with drones now, and so that you can see a much more? Oh, that's going to be very. This is going to be an excellent innovation, I think, for monitoring regeneration work over time. Now, I'd like to introduce Tony Parks. Tony has the distinction of not having a slide presentation because he can actually deliver better without it. Tony is president of Big Scrub Landcare and has provided leadership for the Big Scrub Landscape Level Restoration Project for over a couple of decades now, 25 or so.
25, yeah.
Tony's collaborating with Maurizio Rossetto, conservation geneticist from the National Herbarium to Restore and Renew program, on a project to overcome knowledge gaps and logistic problems to secure genetically appropriate propagule sources for the big scrub. Thank you, Tony.
Thank you very much, ladies and gentlemen. I'm going to tell you today about a fantastic project that we're now embarking on. It's about applying the latest genome science to saving critically endangered lowland subtropical rainforest. It's all about genetics, and our partner, would you please stand up, is Maurizio Rossetto, who's one of the great and acknowledged one of the finest rainforest geneticists in Australia and a leading figure in the world. So Maurizio, we value your input. Maurizio and I have known each other for 25 years, and during that period we have both progressed. He's gone to the top of the scientific heap, and I've had a good role to play in restoring our rainforest. The problem we're trying to solve is the lack of genetic diversity in many species in the lowland subtropical rainforest. The solution we're applying to it is developing a seed plantation modelled on a macadamia plantation that will contain, for the 23 species in our first plantation, 20 individuals that we have selected across their range to have the optimal genetic diversity to cope with climate change, to avoid inbreeding, and cope with other threats like pathogens. Let me talk first about the lack of genetic diversity in the plantings. You've heard about the fact that we've planted 1.5 million trees in the big scrub. Well, that figure now is actually 2 million. And when those trees mature, and they're being planted now at the rate of about 100,000 a year, would you believe, that will increase the area of the forest, to Carla's delight, by some 60%. So that's a huge achievement in itself. But unfortunately there's one issue, and that is the genetic diversity of the species used in those plantings, and that's up to 180 species, is inadequate. And the reason is that the seed collectors would only go and collect seed from easily accessible trees on the roadside or on a friend's farm, and they tended to collect from the same 3 or 4 trees year after year. We got some advice from Julia Playford, who 20 years ago, when we got this advice from her, was a professor of genetics, or botany, specialising in plant genetics at UQ here. And she said in those days, you need to plant with seed from 10 unrelated maternal trees, and they should be local provenance. Well, we've moved on from there, as Maurizio will tell you. If I'd like him to tell us a little bit today if we've got time, but he's giving a much more expansive talk about his Restore and Renew program on Wednesday afternoon. So we realised, and we had great concerns for the 20 years about the lack of genetic diversity in these planted species. And if you think of the effort put in by landholders to plant now 2 million trees, and if you casually value those at $10 or $12 a tree, that's $20 million of landholder investment. And the tragedy is that those plantings won't survive. Most of the species will inbreed, and there'll be a loss of species, and instead of the great revegetated areas we have now, and we've got 14 acres on our farm, they will lose species progressively. So we've been thinking about this for years and wondering what to do about it. And there was a young guy called Maximo Bottaro who, as part of his studies at Southern Cross, I think it was for his honours year, did some DNA work on 3 of the commonly planted species, and he confirmed our worst suspicions that the genetic diversity was very poor and these species were doomed to inbreed. So I asked him how he got his leaf samples out of remnants, and he said, well, he developed a potato gun, which was a length of 50mm plastic tube, and he put a 90mm tube in the back and put a piezoelectric spark generator, filled it up with ether, fired it up into the remnant, and down came the leaves. And so I suddenly had a eureka moment, and I thought, well, if we can't get seed from remnants, why don't we get cuttings from selected trees? And in my simple approach, I thought, well, we'll select 20 trees from remnants scattered across the range from, say, Grafton up to the Noosa hinterland, which is the range of lowland subtropical rainforest. I thought, well, random selection from 20 remnants is better than nothing. But then I talked to Maurizio about it, and he said, oh, that's a brilliant idea, but I want to bring the latest genetic science to bear on this. And what I want us to do is to collect samples from 5 or 6 old-growth trees in 30 to 40 populations across the range of these particular species. And so this was a bit of an eye-opener for me, and I thought, what a fantastic idea that is. So we've been trying to get finance for it. Maurizio and I did a comprehensive budget. We needed about $500,000 in cash for the 20-odd species. He would contribute to $300,000 or $400,000 in in-kind work. We could get together about the same, well, we could get to, say, at least $150,000 in-kind work, and that would match the $500,000. Well, I wrote 3 unsuccessful grant applications because I think the bureaucrats found this project a bit novel, and of course it had long-term implications, long-term outcomes. So I have one more application pending, and if that doesn't work, well, I'm determined that we'll raise funding from our donors to raise the $350,000 or the $500,000 to get this project off the ground. It's too important to not do. I'd like to now turn to the remnants, and as you've heard, the remnants around here are tiny, most of them. They're scattered, and the individual species within those remnants are even more isolated because of the 300-odd tree species in lowland subtropical rainforest. The greatest number in any remnant is 180, And the big scrub flora reserve, which is the biggest remnant left, which is 170 hectares, there's only 160 species. So you can see the species are even more isolated than the remnants, and in many areas their populations are small. And the likelihood is that they are too small to breed successfully. There will be inbreeding, and I think Maurizio said there's already some evidence of that. And of course, in our project, because we're sampling 6 trees from each population, we will be able to get a bit of an insight, at least to some degree, as to what the genetic variation within the remnants are, and then we can look at that across the landscape, and he will do his magic stuff to pick us the 20 best trees for the plantings. But when the plantings, which are continuing, when these trees start to produce seed themselves, and that gets disseminated across the landscape, the quality of the gene flow across the landscape of these species, and eventually our vision is to get to 100 species, not just 23. These good genes will spread across the landscape. They will be more successful in breeding. They should then, as they get into the remnants, they should outcompete the naturally regenerating species which have not good enough genes to survive. So we've got a plantation site. I should talk about the partners first of all. Maurizio is the key partner in the Royal Botanic Gardens, and he's just fantastic. Rob Koyman, who's many of you know of, and he's talking here today. He's one of Australia's, and I guess the world's leading rainforest field ecologist, and he and Maurizio produce research papers in huge numbers. So he's a great colleague of Maurizio's. He's been a great supporter of our land care group for 25 years. So he's doing the cutting collection. We thought we had to make a start on this, so the Big Scrub Foundation has undertaken to fund the $70,000 budget for that activity. It's the first step in this project because we can't hang around any longer. We've got to get going on this. And it's going to be about 8 years to get to fruition till we start harvesting seed from this plantation. So one of our partners is a guy called Rex Harris and his son, and they are big macadamia growers. They are the most innovative macadamia growers, and they apply the principles of biological farming to maca production, and that's what we're going to do in the plantation. He will do the site preparation for us, he will help us design the plantation, and he will help with the planting, and he'll do the ongoing maintenance. Fortunately, his farm, where he has the most amazing array of gear and runs all these great trials, is only a couple of kilometres away from the site. So the other key partner is Mark Dunphy in Firewall Rainforest Nursery. He is the biggest rainforest nursery operator in the Big Scrub, and I think probably in Queensland as well. He will do the striking of the cuttings and growing on the planting stock from the cuttings, which will form the planting stock for the plantation. So the benefits, I probably should read these out because otherwise I'll forget some. I don't like reading, but I'll do it anyway. First, obviously, it will increase or improve the sustainability of the plantations, and I'm hoping that the people that have already planted big areas will be able to plant additionally beside them. In my case, I think we'll probably knock out some of the areas we've already planted, and we'll replant some of these genetically better species. The other thing we need to do, which I should mention actually, a big shortcoming in many of the plantations is that the species are sort of distributed willy-nilly. And to get effective pollination in most rainforest species, which are insect pollinated, they need to be within 50 metres of each other, and certainly no more than 100. Whereas in most cases, the individuals of one particular species are just scattered across these quite substantial areas of planting. So what we want to do is ensure that plantings are divided up notionally into 30 metre by 30 metre areas, and the 20 individuals of a particular species are planted within that area so that they're close enough to pollinate. Because if they can't pollinate, what's the point in doing it? So that will do a great deal for the planting. It will ultimately help the remnants, and I'm hopeful that we can expand the remnant areas by adjacent plantings of the genetically diverse planting stock, and to help the problems in particularly in the smaller remnants. It will help the gene flow across the landscape, which is critical to the long-term survival of this rainforest. So this also, if this model can be applied to other heavily degraded ecosystems, it's transferable, it's innovative, and it applies the best cutting-edge science we've got to enhance the restoration outcomes that we are achieving. Finally, this is the first way I can see that we can overcome the impacts of fragmentation and isolation, which in an area like this where 99% of the original forest has been cleared are critically important. So I think this is the key to saving our lowland subtropical rainforest from extinction. Thank you.
Thank you, Tony. That's excellent. We actually have 15 minutes for discussion now. So all the speakers, you can remain seated. There's no panel seats for you up here. You can remain seated. But if people would like to direct their questions to any of the speakers, that would be terrific. Thank you. Testing? No?
This is a question for you, Tony. I was just trying to understand your project. So you're going and collecting as many samples and then choosing the 20 most genetically diverse. Is that correct?
We'll collect from six individual trees in each little remnant that constitutes a population, and that's there'll be probably 30 populations and 6 individuals of each species. So that's 180 individual trees that Richard will get the DNA. Yeah.
The way we're working this out is we're doing a broad genetic scan across the whole distribution of the species. We look at geographical distribution, environmental type distribution based on models. We then sample between 30 and 40 population. In fact, we'll do more than that because that's 30 and 40 in New South Wales and 30 and 40 in Queensland if they're moving to Queensland. From there, we then and we use just your normal genome scan type of technique. And from then, we've got models that can try to maximize diversity based on the number of individuals that we bring in within the provenance. So we can select provenance and non-provenance. We can define provenances. But what we can also do, as Tony was saying, is that we can bring in specific genes. So if we want to bring in genes from populations that are adapted to specific climatic conditions, or if we were lucky enough to identify populations that have what appears to be disease resistance, we can then bring in some of those genes without bottlenecking the diversity of the overall population. So we can mix the two provenances and maintain genetic diversity high. Sorry, team. Does that make sense?
So if you discover numerous provenances in the range that you're testing, will you be trying to represent all of those provenances?
We'll make decisions according to the species, according to what the situation is. So we're finding that different species do different things. So it will really depend on what the results are for the different species. In most cases, the big scrub will mostly be a single provenance, not for all species, but for the majority of the species. And we might want to bring in some additional material from outside the provenance.
Thank you, both of you. You're not profiling the genome for the whole species along the east coast. You're just doing it. You are. So you're learning whether or not this particular species is genetically diverse across its entire range. What results? Can I just ask what results you've got so far from a couple of species? Just two.
I can tell you that from New South Wales, from the preliminary trials that were done in New South Wales, as you would expect, you have very different patterns between species that are of, let's call it Gondwanan stock, and species that are of Indo-Malaysian stock. So things such as red cedar, for example, of Indo-Malaysian stock, have no structure whatsoever. They're kind of a weed that has just arrived from Asia. And they're very safe. That's right. That's right. So there is diversity there, but it's pretty uniform across the landscape. Other species that are of Gondwanan origins are much more fragmented, and you can see how they have refugial areas in different parts of the landscape have accumulated differentiated diversity. That doesn't mean that it's adapted to those conditions, but obviously it had a long time within the landscape.
Very helpful, and it's such exciting work. Yeah, we really do need to raise that money.
We'll get it, I promise.
That's right, and I believe you. Yes, one more question.
I've got a question for Dan in regards to camphor conversion.
Hang on, a question for Dan in regards to camphor conversion.
So I found with some of the larger camphors in areas where I've done some camphor conversion, where we've stem injected one tree, nearby we've managed to get 3 or 4 subsequent not dying, obviously being affected by the same herbicide. I found then that we've had problems with the glyphosate, not working as well later on when we're trying to stem inject those ones. Did you find any of that happening, and how did you overcome that?
You're talking about stem injecting, having a repeated treatment when the first treatment didn't work very well?
No, it was one tree that was stem injected and then subsequent trees nearby, so whether their root systems have been connecting and then the herbicide travelling through there.
Yeah, it's interesting. Yeah, I have observed that phenomenon, and it seems different sites have different responses. Some, I'm not sure whether they were actually suckers, and so there might be one parent tree, and then there's suckers, and you kill a sucker, and it affects the parent tree, and vice versa. But definitely, if we've had an unsuccessful kill, or killing a tree the second time is always harder. So I guess, yeah, if you're seeing a response from another stem or sucker, I'd say that's why you're having trouble for it to be impacted by the glyphosate, because the translocation isn't as effective on a sick or damaged tree. Yeah, so yeah, we've seen the same thing, mate, yeah.
Excellent. We've got Carmen, I think. Yep.
Well, I've got one for Dan and one for Tony, but I'll ask the one for Dan and we'll see if time later for the one for Tony. So Dan, you said that when you do the technique which involves killing the camphor laurels and planting as well, you got better recruitment because of the soil disturbance. Does that suggest that if you're simply not planting but you're just controlling the camphor, that if you added a disturbance like raking the soil, you might actually improve the technique in terms of getting better regen?
Yeah, the answer was yes, he thinks that might have happened, and it has happened at Broccoli. They did put a ripper through a site and got fantastic results, better than if it wasn't disturbed. And then we've got one more here, and then we'll go back.
Thanks everyone for your speeches, but actually Tony, just a quick one for you. Has the methodology been published yet, or is it available to see?
No.
Okay, it's top secret. And okay, and Ian, I think it was on for you. Just you mentioned at the end of your pres there was something about mammal diversity and how you'd, I think, recently retained or employed someone to do some mammal work, and that it was showing measurable improvement. But do you have any baseline data pre-control that supports that?
Sadly, no. Baseline control is what David Charlie looked at was 3 areas. So one is the old remnant area of rainforest, so a reasonable distance away from the worked areas, and then choosing the older remnant area, which is older worked area, so which is then looking towards 10 years old, and then newer one, which is only looking to say 3 years old. And what he was noticing, there was quite a difference in what was changing is the area, this older regen worked area was then showing a very similar, mostly birds is what's point, but also doing frog surveys. Was finding that the older worked areas were actually supporting what the old remnant was supporting. But no, there's nothing done. What would have been nice is to completely from the word go before you actually start working and then work through. But one of the things of Wampu is that the areas around it was worked. You've got nice primary rainforest or good remnant around the areas actually work. So you're going to get birds in close proximity to the areas worked as well. But there were very large patches cleared. So.
Okay, Tony, I'm engaging my critical scientific facilities in asking this question. It seems to me a very sensible goal to have genetically diverse seed sources for planting, so I wouldn't question that. But I would question the situation with regard to existing plantings using seeds that may be inbred. And my observation would be that based on my knowledge, you know, just general knowledge, scientific knowledge, is that being genetically inbred does not necessarily lead to the consequence that an individual will survive or grow poorly. So I wonder if you are overstating the case with the existing plantings. I mean, is there evidence that you're seeing trees dying because they are from genetically not diverse stock? I mean, you know, some species in nature have very low genetic diversity, are very inbred and manage to survive.
Now, I think Maurizio can answer that question.
Yeah, that's an excellent point, Carla. In the majority of rainforestry, from what we've seen, tend to be preferential at crosses. The issue there is that, as you say, you can plant the tree and it will do very well. But when you're planting 100 trees that are closely related, it's the progeny that you need to worry about. So what Tony was talking about is the long-term productivity of a forest that is actually re-established using very, very closely related individuals, and that's where the greatest risk is. So in the producing fit and actual numbers of progenies, and we're having the discussion with Tony. It'll be interesting to see if anyone has good data where they have monitored the reproductive potential of planted reforested areas in comparison to non-reforested areas.
Thanks, Maurizio. And I note that if one of the measures of functionality is reproductive capacity, then the natural regeneration that has occurred is demonstrating functionality. So I think, Tony, you might have commented that, you know, the regeneration might not be viable in the long term, whereas the fact that it has regenerated already is showing some functionality. Wouldn't you agree? At least with respect to being able to reproduce.
I thought I heard you say something about perhaps removing some trees from... Did I hear you say something about removing trees from existing plantings, which to me sounds like a really silly thing to do if the important goal in restoration is to expand the area covered in forest. And you don't know if the existing plantings are going to be good or bad in the long term, but you could improve things by planting nearby, extending the planting with more genetically diverse stock, then do it that way.
I would agree on that one.
Yeah, and in practice though, for a landholder, they might not have the space and they might have to actually create gaps in which they can put these things in. That's Tony's very problem. But we have a question up here. I'm not singing through the aisles like this.
Hello, this is just a question for Ian about MERV. Is that a publicly available methodology or is that more in-house to your organisation?
I think we're getting close to the last question. Have we got another one?
Very quick one.
Yep.
Very quick one. And we've done a long-term cost comparison of patch in Australia. Well, obviously the patch is line, like cost emissions. I don't know if it's taken out over time.
I don't know off the top of my head, but Carlo's actually written papers on it, I believe. Yeah, it's online, yeah.
It's Kanofsky and Catterall, and there's a kind of a report which can be downloaded from the web. Yeah, if anybody wants to email me, I can send it to them.
Thank you, everybody. Now, we've had a terrific session. It's been recorded by Regen TV, and if you have any problems, if you've asked a question or your face is shown on the TV, which I don't think it will be, just let us know at the Arbour store, at the Arbour trade table. We'll also be combining it with some footage from the Big Scrub field trip prior to this conference. So watch out for that over the next 6 months. It has to go through an editing phase. We thank all the speakers and for the audience.